Today I want to look at the Teensie 3.2 development board, using it both as a MIDI input and output device to a keyboard via a DIN connector and also to a computer via USB. Now you can find a lot about MIDI on the pjrc.com website. Go to pjrc.com and click on Teensie at the top here, and then Teensy Arduino on the left here, then libraries, and finally MIDI, and there's everything you need to know about MIDI and the circuit to connect a Teensie 3.2 to your keyboard via a DIN connection. So what I want to do is four things. First of all, make a MIDI output circuit using 4 buttons to play 4 different notes on the keyboard, then a MIDI input circuit to receive messages from the keyboard, coupling them both together into a MIDI input and output circuit, and then finally using the USB connection to pass those messages onto a computer so that you can get a DAW or Digital Audio Workstation like Cakewalk to record and play your MIDI playing. So here is my breadboard layout for the Teensie MIDI output, and here's the 5-pin DIN socket with two 47k resistors, one of which is tied to 3.3 volts and the other one tied to the TX pin 10 on the Teensie. There's the 4 buttons. One side is connected to ground, the other side is connected to pins 0, 1, 2 and 3 on the Teensie, and the Teensie itself, which is under this audio shield, which is not required for any of these experiments. So let's look at the MIDI output software. First of all, you've got a bounce library which deals with the switch bounce in this section, then the MIDI library itself, and then this MIDI create instance which sets up the serial ports. I'm using serial port 2, which is the TX pin on pin 10 of the Teensie, because if you have a look at the Teensie card, TX2 on pin 10 there, because I can't use TX1 on pin 1 because that is used by one of the buttons. So if you look on to the main part of the program, we check all the buttons to see whether there's been any changes, and you use the falling edges as note ons and the rising edges as note offs. So because there's 4 buttons, you've got 8 if statements. So you send a MIDI note on, middle C, key velocity of 64 on channel 1 when you press the key, and when you release the button you send a MIDI note off, middle C, key velocity of 0 on channel 1. So that's essentially the MIDI output routine. So let's have a look at the hardware. So here's the Teensie connected to my keyboard, and if I press one of the buttons, and I can even press more than one button. Notice if I hold the button on, you can hear that there hasn't been a MIDI off command sent until I release the button. And if we look at the Arduino serial monitor, we can see that the note on and note offs have all been detected. So that's the MIDI output routine. Now let's have a look at MIDI in. Here's the Teensie breadboard with the MIDI input circuitry added, the 5-pin DIN socket, a 220 ohm resistor, the diode between pins 2 and 3 of the 6N138 opto, a resistor connecting the output of the opto to 3.3 volts. Don't forget that the opto is connected to V-in, which is 5 volts, and the output from the opto goes to RX pin 9 of the Teensie. Looking at the MIDI input software this time, we've got the MIDI library here and the MIDI serial port set up. This time it's on RX pin 9 of the Teensie, and we also set up the speed for the MIDI transfer at 31 to 50 bits per second. Looking at the main loop of the program, this is more involved than the output routine. Basically you have to receive 3 bytes, a status byte which is converted into a channel byte, and then there's a velocity, key velocity, and a note value byte. When all have been received, you then print to the serial monitor the details of those, but you've got to account for this weird situation where a key velocity of 0 does in fact equal a note off, even though it might be a note on command. So that's got to be accounted for here, and then in the case of MIDI note off, you then do exactly the same thing, try and receive the 3 data bytes, status byte and 2 data bytes, and then print the details to the serial monitor. Once again, I've connected the Teensie to the keyboard, and the buttons this time don't do anything. I'm connected to the MIDI in socket, and if I come over to the keyboard and play middle C, if we look at the serial monitor on the Arduino, we get data, so it works. So if you merge the MIDI input software routine with the MIDI output software routine into one program, you can get it to do both things at once. And I've done this here. First of all, you've got the output routines on the buttons, and then you've got the input routine to receive data from the keyboard. So let's have a look at the hardware and see whether it works. So now the Teensie is connected to the keyboard using both the MIDI input and output sockets. And if I press the buttons, the MIDI output routines work, and if I come over and press keys on the keyboard whilst watching the serial monitor on the Arduino, that works as well. Success! So how do you alter the software to now pass this MIDI data onto the computer? Well, if you go down to the MIDI input routines, you just have to add this one extra line of code. It's a send note on, but this time it's a usbMidi send note on command, and you do that for each of the 8 sections. And then when you get to the MIDI input routine, before each serial print line command where you print the data to the screen, you add in this extra line of code, which is pretty much the same thing, but this time instead of using the actual numbers, you use note, velocity and channel. So this is the usbMidi command. To test this extra bit of software, I use a free program called MIDI OX, which looks something like this, and it just monitors any MIDI information coming into your computer. So if I press a key on the keyboard, there is a note on and a note off command received, so it works. And I also have got a pedal command there, which is a controller, and this is because I've added an extra bit of software into the routine, a case MIDI control change, which adds that functionality. So now it's not just a case for MIDI note ons or note offs, we've also got the control change. So let's try and boot up the Cakewalk software now to see whether we can record and play back a sequence. Okay, so I'm at my keyboard and I've got Cakewalk running on the computer, and I've got the Teensie connected to the keyboard. Let's go ahead and record something. Let's stop and play it back. Look, no hands. It was all done with the Teensie. Let's just hear it again just to make sure. So that's what you can do with just a little bit of playing around with the Teensie.